In this unit, I'm going to cover three primary topics. We're going to talk about how to select data from multiple tables. So how to combine tables using a join. We did this a little bit previously, but this week I'm going to talk about it a little bit more formally. I'm also going to have a presentation on doing subqueries and also one on views. And that'll conclude the SQL topics in this course as far as SQL syntax goes. So let's get started. So first, we talked about creating, how we design databases and, having relations that have, a reference to one another. We talked about foreign keys and so forth. But one of the problems with that, right? So if we start out with a table that's a complex set of data, we created these different tables to separate that data and normalize that data, right? So, and as an example, right, I used the example before of, let's say we had a customer and invoice and sales and an item, and then we kind of created all these relationships, and then we put extra tables in when we had to, for example, resolve many-to-many relationships. So I kind of went through that example in a previous lecture. So what we end up with is a database that contains many tables, and we have to have a way to relate that information. So users aren't accustomed to looking at data like this, right? So here we have a whole bunch of data from all these different tables, right? So this is maybe an example of what that database might look like that I just showed you, right? Here we have items, we have invoices that contain those items, we have lines on that invoice, we've got the customer database, we got the salesperson, right? So we've got all this stuff, but how does it relate to each other? Well, if we look at this, we know that there's foreign keys and primary keys, right? So we know that we have these are line items, right? The line item is the primary key, but the item references the primary key from the item table. And likewise, on my invoice, I also have, on my line item, I'm also going to have an invoice number, and that's going to reference my invoice table, right? And on my invoice table, I've got a salesperson, which references the sales table, and then I also have a customer ID, which is going to reference the customer table. And somehow I need to be able to put all this stuff together so I get one view of my data so that my user gets a report that's readable, right? This is more like what our users of a database would expect to be able to get, right? So they're going to need to be able to join these multiple tables together. So there's a couple different ways to do this. There's this sort of what we call a traditional way to do a join, the old-fashioned way, right? SQL 99 does support this, where we select our column names from and we list the table. So instead of just having one table, we're going to list multiple tables. And then we're just going to do a standard where clause where the field from table number 1 is equal to the field from number 2. It'll only show those records. What's really happening here in the background when you do this is just taking all the records in table 1 and combining them with all of the records in table 2 in what we call a Cartesian join. And I'll show you what this looks like here in a few minutes. And then it's filtering that Cartesian result to only show you where the columns are equal to each other, right? So this is not a terribly efficient way to do a join. Typically, what's a little bit more efficient is using the join operator, because you're telling the database engine how you want to join these two tables together. So typically, after you do your select from table number 1, you'll do a join to the next table. So instead of a comma-separated list, you join the next table, and after you join a table, you have to tell the database engine how you want to join those. So what are the parameters to join those? And this is a little bit like that where clause that you see in my first example. If you try these in your database, they'll both work. They will both give you a result. They'll both do what they need to do, but the second one is sort of more of the accepted standard way to do joins. There's more interesting things you can do with the second option. The first one doesn't support a lot of things. And of course, after you do your join with the join method, then you can list your where clause. So this is where you would continue with the rest of the syntax that you can use in SQL that we've already learned about. So let's take a look at what that Cartesian join is. These are not common, right? Most of the time when we do a join, we're not interested in doing a Cartesian join. But this is the default. If you don't tell the database how to join two tables together, it's going to do a Cartesian join. So this is where we just list the different tables. So what happens is the database engine is going to take the record on table number 1, the first table you selected, and then it's going to combine it with the record that it finds in table number 2. And then it's going to take record number 2, then 3, then 4, and so forth and so on. So it's going to completely combine everything from table 1 to table number 2. Then it's going to move to the second record in the first table, combine everything from the second table, then the third, combine everything from the second table, and you can see we get a pretty long list of results, right? So, and what you would normally do if you wanted to figure out how many results you're going to get in a Cartesian join, you just multiply the number of records in the first table by the second table, and that's how many records you're going to get. So with a large table, like take the some of the tables from our assignments, that would be a pretty big result set, right? So that's an example of a Cartesian join. And like I said, this is not common. We typically don't do a Cartesian join. There's not really a lot of scenarios where you would do this, but certainly you're welcome to discuss those in this unit. Try to figure out ways that you might use a Cartesian join. The way to do this, if you want to use a join, you would use the cross join keyword. So if you want to, instead of just listing your table names, you could in SQL 99, in the SQL ANSI standards, you would do cross join instead of just listing your tables. But both will work in most database engines. You could do it either way. In fact, some database engines don't support the cross join keyword. You have to just list out the different tables. All right, so let's keep going here. So we can also do what's called an equality join. This is probably the most common type of join, where we simply want to join two tables based on the values in the foreign key, right? So in this case, I've got two tables. They both have a CID, so that's how we're going to join these tables, right? And it's pretty obvious in this case. So here, if I just select from customer and address, and I say where the customer CID is equal to address CID, I'm going to get the results that I'm looking for, because it's going to combine it based on those fields, right? So it's not going to show the rest. Now the reality is, what's really happening here is that Cartesian join is happening first in the database engine, and then it's figuring out which things are equal, right? So again, this is the traditional approach, but and we end up with the records that we're looking for. But with the traditional approach, we would do, one option is to do what's called a natural join. A natural join works without the on keyword. So normally you have to follow up your join with the on keyword and tell it which columns you want to join on. But you don't have to do that here, because the CID is the same column name in both tables. So that's a natural join. It basically says, okay, what's the primary and foreign key, and they have to be named the same things in certain database engines. Although some database engines, this works if you use the references keyword when you create your table, right? So if you make your foreign keys when you create your database, sometimes this will work. But in any event, natural join works here because either we've defined it in the schema or because they have the same name depending on the database engine. So that's the simplest type of join. But that's not typical, right? So we typically can't use a natural join. Usually our tables are a little bit more complex than that, and we want to be more explicit in how we're going to join these different tables. So the way we explicitly tell the database engine how to join these is you can do, this is one syntax, right, where you add the join keyword, but then you just say using, and then in parentheses, the column that you want to join. So that just says look for that column name in both tables and use that to join the two tables. So that will work. The other method we have to doing an equality join, and this is the most common way to do this, right? This is where, let me just take a quick step back here. So typically when I show these examples, to save myself some typing, and I would expect that most of you would do this too in your assignments, instead of just selecting the table names, we learned how to do this earlier, we're going to use an alias, right? So instead of customer, I'm going to do customer space C. C becomes the alias for the customer table. A becomes the alias for the address table. And then when I reference those columns in my where clause, I just prefix them with just C or A for a customer and address. Just a little bit easier, right? So we already learned how to do this, but here is the syntax that, again, this would be the most common way to do an equality join. We use the join keyword. So I'm joining the table address to the table customer, where the address.cid is equal to the customer.id. And again, I could use my aliasing as well, right? So you can see the syntax changes a little bit when I use the alias. Let's look at another example. Here we've got a invoice table, a customer table, and a sales table. So we have three tables. And in our invoice table, it looks like we've got an invoice ID, a salesperson, and a customer. So we can join this to these two other tables. So in this example, I have more than one join that I want to do in this example. So one way I could do this is the traditional method where I just select from all three tables where the invoice customer equals the customer.id, right? So where those two columns are equal. And then I can add to that where the invoice.sales is equal to salesperson.id, right? So where all of this stuff is true, and that's going to give me just the records that I'm interested in. By the way, when I do that, I have to change my prefixes. I'm sorry, I didn't alias here. If you aliased, you would have to change your prefixes. So that would work. That would give us the results that we're looking for, right? So let's do this a little bit different, right? So this time we're going to use the join keyword. So I'm going to select from invoice. I'm going to join customer, where invoice.customer equals customer.id, right? And then I'm just going to do another join. I'm just going to tack another join onto that. So this is how I would join from multiple tables. You can have lots of tables joined together, not just one or two. You could have a list of, I've done queries where I have a list of 10 or 15 tables that are joined. It's not very efficient, right? And that's one of the reasons we talk about denormalizing a database, because if we have to do a lot of joins, it adds a lot of resources and effort for the database engine to work with those queries. But in any event, this is how you would do a join on multiple tables with an equality join. So fairly straightforward. And we get the results that we're looking for when we do that. So a non-equality join is where we're joining, but not necessarily where two fields are the same, right? So we're not using the equal sign as our operator. We're using something else as the operator. So in this example, let's say I've got some items, right? I've got a widget, a thing, an object, and a who's or what's it, right? I've got a bunch of different objects that I want to work with. And then I've got shipping rates, right? And the shipping rates are defined based on a range of the weight, right? So if anything that's from 0 to 1 pounds has a rate, then from 2 to 10 pounds, 11 to 20, and 21 to 30. So if I want to get the shipping price for these items, I want to join these two tables so I can show the shipping price, I can't just do an equality join because the 4 is not going to be equal to any value in that second table, right? The first one will work, but all the other ones are going to fall somewhere in that range. So I have to do a join based on a range. So how would I do this with a where clause? If I were doing a where clause, I would simply ask for all the records where item.pounds is between the shipping rate minimum pounds and shipping rate maximum pounds, right? So this is one way to do it. This is the traditional way to show these two records. But as I said before, typically we like to use the join keyword instead. This is the more acceptable way to do this. So I would it's very similar, right? So I say join the shipping table on where pounds is between the minimum and the maximum from the other table. And when I do that, I will get the prices for shipping based on the ranges of the weights of these different items. So that's how we join where it's a non-equality join. Another type of join is a self-join. So a self-join is when we're joining one table to itself. So instead of joining to something else. This might be sort of like if you recall from our database designs, right, we talked about a unary relationship. So if you have a unary relationship in your ER diagram, it would probably manifest itself in a query as a self-join. So we can join to a table that's the same table, right? So in this case, I've got a list of people and they have a spouse, and the spouse relates back to the person, right? The classic example of a unary join. So in this example, what I want to do is basically have more or less a copy of that table that I'm going to join to, so I can find the the names of our spouses, right, in this table. So to do that, I'm going to select the first name, and then the first name, the name on the left, with the name on the right, which is the spouse. So I'm aliasing s.name as spouse. So now I have two tables. They're both family, right? They're both from the family table. I'm selecting the family table twice, but only where the spouse is equal to the where the family person's ID number is equal to the spouse's ID number, right? So that's the traditional way to do this, and it gives me my answer. But then there's also the join way to do this, where instead of doing selecting from both tables, I just join the second table, well, really the table to itself. One thing is, when you do a self join, you have to alias the tables. It doesn't work well if you don't alias the tables, because then how does the database engine know which columns you're trying to select from which table, right? So it's important to make sure that you use aliases when you do a self join. But pretty much everything that you would do with a join on multiple tables will also work on a self join. So it works pretty much the same way. You can also join tables in different, so far we've looked at joins where we're only showing records that overlap on both sides of the join, but we can also do a left and a right outer join. So what I've described previously is called an inner join. An inner join is where we only show the overlapping records. An outer join is where we show all the records from one of the tables and then only the overlap with the secondary table. So you can see in my example here, I've got a list of customers, and then I've got a list of invoices. And if you look at this, there are, there's a foreign key for customer on the right-hand side, right? But there are some customers who do not have an order. So for example, Petra on the left side does not have any orders. Oh, I'm sorry, Petra does have an order. Who doesn't have an order? It looks like Champy does not have an order. So Champy does not have an order. So if I were to try to join these two tables, as you see here, right? If I just do join invoice ion customer equals customer ID, right? Kind of the way we've learned to do this. I am going to get a result set that is not showing all of my customers, right? So I see that Julianne and Champy are both missing from my join, and also there's an invoice here for which there is no customer, right? So it goes both ways. There's some invoices with no customers and some customers with no invoice. So a typical join is only going to show a small set of records. We're not going to see customers that don't have an invoice. So what if I did want to see customers that have an invoice? One way to do this, if you're doing a traditional join, you just add a plus parenthetically to the table where you want to show all the records. So in this example, it would show all the customers, and then only those records and invoice that have a customer. So it'll list all the customers. If it's missing, if the customer doesn't have an order, it just leaves it blank. Right, so that's and you can see here it's null. Sorry, when I said blank, I meant null. Right, so if you look at the fifth line in my result set, you can see that that one of these invoices has a null value for the customer because there is no customer for that. Right. So I'm sorry, that's invoice. I put the plus on the invoice side. Right, the I is invoice. I aliased it. So it's showing all of my invoices because I have the plus sign next to invoice, and then only customers that have matching invoices. And you could do it the other way too, right? So I could show all the customers instead. So now I've got all the customers. Even if they don't have an invoice, it just leaves the invoice date as null if they don't have an invoice to show. So that's one way to do this. But really the way that your textbook is going to show you how to do this, and the right way to do this, arguably, is to use the join keyword. But instead of just join, you're going to do a right join or a left join. And I'll explain what a right join or a left join is. So look at the join keyword. There's a left side of the join, which is, in this case, customer, and the right side of the join, which in this case is invoice, I, right? So if I do a right join, that means show me everything on the right side and then any matching customers, right? So then I'm going to see anything that is on the right side. So I see, in this case, I see all of the invoices and then any matching customer for each of those invoices. So the right means the right side of the join. I could do likewise the left side. I could say show everything in customer because that's the left side. So show all of my customers even if they don't have an invoice. But then if they have an invoice, show the matching invoice, right? So now I see the other option. So this is very similar to what we saw before, but this is using the left and the right join. You don't have to put the word outer in here, right? So theoretically, this is really an outer join. In some database engines, you can put left outer join and right outer join, but it's kind of redundant because there's no such thing as a left or right inner join. Inner joins are, there is no left or right. There's no laterality to an inner join. So usually most database engines, you can just put left or right in front of the join, and implicitly it's an outer join. So that's a left and a right outer join again that lets you control what you see. You can also use a full join in some database engines. A full join is basically where you combine all of the records, right? So regardless, so basically on both sides, right? So I'm showing all of my invoices and all of my customers, and if there happens to be a match, it's going to show the match. Okay, so again, don't get this confused with a Cartesian join, which is a little bit different, right? If you recall from before, the cross join or Cartesian join shows all the records multiplied, right? So you'll see a lot more records. This is probably more typical for what someone's looking for. A lot of times when users make mistakes with the database engine and do a Cartesian join, this is actually what they meant to do, a full join. So finally, we have set operators. So I'll show you an example of this. I don't think your book really talks about this, so I probably won't have this on your test. But basically, set operators are where we can combine multiple tables with a union, right? Actually, your book does talk about unions. I take that back. I'm sorry. So we do have unions in the textbook. But let's say I've got two different tables, right? I can combine these two different tables into one table when I do my select statement. So basically, I select two tables, put a union in the middle, and it will just combine the records from both. It just adds one to the other, right? So it takes all the records in the first table, and it unions it to all the records in the second table. So it just stacks one on top of the other. So it takes all the records in the first table and stacks it on top of the records from the second table, and that's it. The caveat to doing a union is you must have the same columns, and each column must have the same data type. They have to be listed in the right order. The only thing the database engine is going to check is that you have the same count on the number of columns, and each position of those columns is the same data type. They can have different names, right? The different columns could be different names, and the union will still work with most database engines, but they must be the same data type, and they have to be the same number of columns. So same number of columns, same position within each list has to be the same data type in order to do a union. This is the simplest form of a union. There are other types of unions. For example, a union all is where we simply take all the records from the first table and we union with all the records on the second table, which is the same as just using the keyword union. This is just a little bit more explicit. Some database engines require to use the union all. The minus is a little bit different than a union. With a minus, what we're doing is we're taking the first table and we're selecting all the records in the first table, but not the ones that appear in the second table, right? So then we just end up with 4 records here. So we find, any records that match in the second table, we subtract those or minus those from the first table, and then we get our result. So this is only showing you the things that only exist in the first table in your minus, when you do this type of union. All right, the next example is an intersect. This is only going to show you where there's an intersection between these two tables. So only where there's a value in both tables. So that's going to be an intersect. So we have a union, union all, minus, and intersect. Those are the basic union operators. That's it for this video.